Hey, Castle Hill scientists. I'm definitely paying for it this afternoon on my run for sleeping in. Gotta pay my dues. And the reason is that I'm halfway through my run. I went down the wash and the wind was in my face the entire time. I mean, I'd rather be running uphill with no wind than running flat in the wind. It totally changes everything. So I'm thinking, this morning when I got up and I walked out with my dog, there's no wind at all. So what is different? What's different from this morning when it was nice and calm to right now where it's really kind of blowing? And I gotta wonder, does it have something to do with the sun is blinding us right now? Or maybe it's the mountains. Do they have something to do with it? I can see some clouds up on the mountains. We know what that's all about. Now, I gotta go home and think about this and set my alarm for early in the morning and hope it's not blowing like this. But there is really one nice thing, but there is one really nice thing about running into the wind is that when you turn around, you get the wind at your back. Yippee! 7-minute miles, baby. Oh, shoot. I'm definitely paying for being lazy. I am paying for being lazy this morning and not getting up for a morning run. I went this afternoon, and half of it I was running into the sun, into the wind, which is a total bear, and then turned around and came back. Had the wind at my back, and that was okay. But this morning when I walked over to school, there was no wind. And then this afternoon, there is wind. So where did it come from? And where's it going? It's kind of like the water cycle. Does it have anything to do with the sun? Well, probably. Everything has to do everything with this. Does it have to do anything with the sun? Probably. Everything has something to do with the sun. Or maybe the mountains? There are those clouds again. You know why they are there. Well, I'm going to have to go and think about this wind thing. Let me think about it a bit. I'm going to let you know what I come up with. Maybe we can make an experiment out of it. Hello, Castle Hill scientists. I did a little research and I found out why the wind blows. It is the movement of air from one place to another, and that's what causes weather vanes to point in one direction or the other to show us where the wind's coming from. But why does it move? And it has to do with the sun. See, the sun pretty much has something to do with everything on Earth, all right? Because it provides energy. And when the sun's radiation is hitting the Earth, it warms up different places differently. And that's because some areas will absorb heat very quickly, some areas will absorb heat very slowly. Now, if you say that there's something that has a low heat capacity, okay, like the beach and sand, it heats up very quickly. Something that has a very high heat capacity, like the ocean, is going to take much longer to heat up than the beach. All right? And these two differences in temperature is what causes the wind. But you're like, wait a minute, how can the temperature cause wind? Well, it has to do with what's happening to the air above those two places. So when the sun heats up the beach, air molecules get all excited and they start to expand and they're going to rise. All right? They become less dense. In that area above the beach, because the air is less dense, it's going to have a lower air pressure. Okay? Things are going to float away. On the ocean side, because it hasn't heated up as quickly, the molecules are not moving as fast, and so it's going to have a higher pressure. You can just think of it, the air is pushing down harder on the ocean than it is over the land. All right, well, as this air goes up, there's some space here, so the air from the lower air pressure area is going to move over onto the sand. And that not only, the ocean and the beach example is wonderful because we've all experienced it, we've all been to the beach, we've all looked out at the ocean, we can feel that breeze coming in from the ocean and going towards the land because the land is hotter and the air is going up and the ocean is cooler and the air pressure is lower and it's coming. But the same thing can happen on land as well. Now there might be an area that is very dark in color, and that's going to have a higher heat capacity than an area that is lighter in color. Now, to show you this as an example, all right, I've been heating up some beach sand here. Mr. Bones thought I was a little nutty when I was warming up my sand, but now he understands what's going on. I'm going to take my sand and pour it into this pan. And next to it, I have some ice water. All right. So I have my warm sand. The air above this pan is going to have a lower air pressure. It's going to go up. Over here on the water, the ice water, it's going to have a higher air pressure and push down. So when I take my candle or my incense, so I have my little smoke indicator here. So which way is the smoke going to go if I put it down next to each of these plates? Let's find out. Okay, while the movement of the smoke is not super dramatic, we can see that as it's leaving the incense stick, it's veering over towards the sand just a little bit and then rising up. So now that we know how wind is created, I want to show you how you can tell where the wind is coming from, even if there's a very, very light breeze. Now, you might say, well, what's the big deal? You just walk outside and, whichever way the wind is blowing your hair, or take your finger and hold it up. Yeah, but we can be a little more accurate than that, and we can identify the direction, north, south, east, west, that the wind is coming from. And that is done by making a weather vane. Now, often you've seen weather vanes on top of barns. There's the traditional rooster that has an arrow on it and the big tail in the back and the smaller head in front where the arrow is pointing. Do you ever wonder why they choose a big rooster for that? Well, you're going to find out. First thing you need to do is make an arrow like this. That's about 10 inches. Here's another one. I find that cereal box material works well. This is a manila folder. Cardboard works pretty well also. Can be hard to cut sometimes. After you have your arrow cut out, what we need to do is to create an imbalance of mass from one side of the arrow to the other. And we're going to do that by adding some pennies. And you'll find out why this is important in just a second. For this one, paper's a little heavier. I added 2 pennies. Now, if you have a lighter piece of paper like this one, probably just need to add 1. Now, my arrow is lopsided. I try to hold it on my finger like this, halfway through. You might think, okay, well, this side is about as big as this, but it's going to flip over. Here, Bones is going to demonstrate right here. Now, this one doesn't have any weight on it, and so he's finding the center of gravity where it balances perfectly on each side. All right, but remember, this has no pennies, so it should balance about in the middle. Ours, however, has weight on it. And now we need to find the center of gravity. I'm going to use a push pin, And I'm going to start up near the front here, and I'm going to poke my pin in, move it around a little bit so the paper doesn't grab onto the pin. Okay, so that is not my center of gravity, obviously, because the tail end is pointing down, other end's pointing up. So I'm going to go back a little bit more. Getting warmer, Doc. All right, that was too much. And this is just right. It's off a little bit, but this will work. All right, now, the reason that the weather vane works, and the reason that they always have a rooster with a big tail on it, is that at the front of the weather vane has more mass, and the back of the weather vane has more surface area. So when the wind is blowing, it's going to pass by the heavy front part, and it's going to actually squeeze, the wind is going to squeeze on either side of the weather vane to cause it to go straight. So you got equal pressure on both sides, and it's going to cause the weather vane to point into the direction of the wind. So after we've got our center of gravity figured out, we need to get a piece of string and tie it to our weather vane so we can hang it. You'll probably need to make that pinhole a little bigger, so I'm just going to use a pencil and push it in either side. If you have a paper punch, that would work as well, but I also want to give everybody options, because if you don't have a paper punch and you can't find one, well, you don't need one. You just use this pencil. Okay, now we'd be tempted to say, all right, our weather vane is done. All right, but not really. All right, because the way that the string is going through like this is going to influence the movement of our weather vane, even if it's very slight like this. All right, to get around that, what you need to do is tie a very simple overhand knot around the string that's going around the other string. Got it's looking like that. I tighten that up a little bit, and it's also be called a slip knot. And now it's going to hang down straight without any unnecessary influence from the string. Let me demonstrate how this is going to work. I've got a fan to my right. I'll turn it on. So I'm going to put it to the side like this. I'm going to gently move it into the wind. It's pointing away. Now, as the wind squeezes on the back of the arrow that has more surface area, points right into it. I'm going to try to even move it around a little bit, and it's pretty much always going to point to where the wind is coming from. We're going to have Mr. Bones demonstrate how well this weather vane works. I got my fan right here, and as I bring the weather vane into where the wind is blowing, up here, and you can see that where we have more mass in front is going to be pointing towards the wind, and in back the wind is pushing on both sides so it goes straight. Now let's see what happens when I move the fan. Okay, the weather vane is going to follow the wind where it's blowing from. Okay, now it's pointing this direction. Now, just for fun, I thought, well, let's see if I can make this a weather vane. Okay, that's way off. I'm going to add another penny instead. Okay, I'm going to have to go back a little bit. Okay, it looks like we've got a winner. Well, this time I am going to take my hole punch. Okay, we'll see how this one works. It's okay. I think the problem with this one, for one, I don't quite have the center of gravity in the right spot, and the surface area on the back could be greater. But, you know, this is all about problem solving, using different materials, seeing what works, and having fun with science. I hope you've enjoyed this little video and have learned something about why the wind blows. Take care, everybody.